So the first thing we're going to look at is just the difference between this word and this word, the difference between verify and prove. When something asks you to verify, it's asking you to show that it works for a specific number. When something's asking you to prove, it's asking you to show that it always works. Okay? So we set things up basically the same way. So here I've got A, and I'm going to have my left side, and I'm going to split it up on my right side, draw that line down the middle, so that I have my left side and right side. This is for verify. We'll do verify first. So whether you're verifying or proving, you're going to set up a left side and a right side. The difference with a verify one is they give you a specific angle, 30 degrees. So you plug that in. So I need to do secant of 30 degrees, and then 1 plus cos of 30 degrees on this side. And the other side, I do 1 plus secant of 30 degrees. So we plug in the value for theta, and now it becomes a pi plate question. 30 degrees is your pi over 6 family. Cos of 30 degrees is root 3 over 2. So secant of 30 degrees is 2 over root 3. And you can do that on this side as well. And then we have 1 plus cos of 30 degrees, which would be root 3 over 2. Our goal is to use algebra skills and fraction skills. We just need to make the left side exactly the same as the right side. Okay? So just looking at any suggestions for algebra, what we could do. What's that called? Yeah, we could just do this, right? That would work. What's the math word for this? Distribute, yeah. So if we distribute this through like this, well, 2 root 3 times 1 will be 2 root 3. 2 over root 3, sorry. And 2 root 3 times root 3 over 2. Can you see that that's going to equal 1? Can you see when you multiply that, the 2's would cancel out, the root 3's would cancel out in those fractions, and you would just get plus 1. And again, therefore, the left side equals the right side. You've shown what you were asked to show. Fancy shading. There we go.
Do we have to do it on the right side, or can it be anywhere in the paper?
No, that can be anywhere. You can put it underneath what you just did. So that's a verification. For a proof, I'm just going to make this a little smaller. I can make it bigger afterwards if you can't see that. For proving it, we're going to, again, write the same thing. So we've got secant theta, 1 plus cos theta. We want to prove that it's equal to 1 plus secant theta. Every time I do a proof, I rewrite what I want to prove. And then I draw a line here. And then we want to show that our left side is equal to our right side.
So I should forget from yesterday. All you need is the 3 dots, LS equals RS, right?
That's right. So now, we can do a bunch of things here. You can change secant to 1 over cos. Sometimes people like to do that, like to change everything to sine and cos, because every single thing that we have can either be changed to a sine or a cos, because tangent is sine over cos, cotangent is cos over sine. Secant and cosecant are just 1 over cos and 1 over sine. So I'm going to do that, even though there might be a shorter way. But I'm going to do that. I'm going to change secant to 1 over cos. Just, that would be there. And this side would be 1 over cos. At least now both sides have the same trig functions. Again, same thing that we did for distributing. I could distribute the 1 over cos. 1 over cos times 1 is 1 over cos theta. And 1 over cos times cos becomes, this would be cos theta over 1. How do we multiply fractions? Multiply the tops multiply the bottoms, and you would have cos theta over cos theta. Now, of course, cos theta over cos theta is 1, and I still have 1 over cos. And my left side is equal to my right side. So I am done and have proven what I was asked to prove. There's a B. I want you to try B on your own. Okay? Yes? I'll put the verify in the proof for B so you can check how you did. I'll start with the verify. And it's still 30 degrees, right? Yeah. So you have 1 minus tan of 30 degrees and cotangent of 30 degrees minus 1 over cotangent of 30 degrees. 1 minus root 3 over 3, because tan of 30 degrees is root 3 over 3. So cotangent will be 3 over root 3, which is the same as root 3. But how many people did 3 over root 3? Did most people do that? I'll show you how to do it, because there's a little bit more math involved if you wrote 3 over root 3. Okay? Now we need these to look the same. Again, one of the biggest strategies that we're going to have in this unit is if we can get everything to a single fraction on both sides, most likely they're going to be the same. So on this side, to get this to a single fraction, I would need a common denominator, so 3 over 3, and then I would have 3 minus root 3 all over 3. And I have a single fraction that's simplified. On this other side, I have a fraction on the top and a fraction on the bottom. So I'm going to multiply my 1 by root 3 over root 3. My goal is to get one fraction on the top, one fraction on the bottom, because if I have a fraction divided by a fraction, I can multiply by the reciprocal, and then I'll have my simplified answer. I'm not going to multiply by the reciprocal yet, because I like to have one fraction on the top and one fraction on the bottom first. That's going to simplify things for you. So here on the top, I would have 3 minus root 3 all over root 3. And on the bottom fraction, I have 3 over root 3. One of the things you're going to sort of notice while you do verifications or you do proofs is sometimes you have a lot of fractions. Okay? Some of the things that I do, you notice how I made a bigger line or a longer line for the middle one just to help me see what was part of the fraction. I also like to leave space in your notes. It might even be a good idea to leave a whole line in your notes, because otherwise you just have fractions on top of fractions on top of fractions, and you might start taking the wrong part of a fraction to the next step. So that just helps you keep things clear. So again, I'm going to leave a little bit of a space, but now I can multiply by the reciprocal. This is grouped together because of the subtraction sign. These are identical, so they can simplify. And we're left with 3 minus root 3 over 3, which is the same as the other side. Perfect. So we verified it. Now, verifying is just about as much work as proving. And proving is more powerful, because once you prove it, you show that it always works. So proving it means that, yeah, you can just say it works for 30. It works for 45. It works for 37.2 degrees. Whatever angle you want, it works for. The only restrictions is if you would pick something that would make you divide by 0. So certain things aren't allowed just because you can't divide by 0. So you wouldn't cotangent equals 0 at pi over 2. That wouldn't be allowed. Tangent isn't allowed at pi over 2 either. So now we're going to do a quick proof of this. Again, write it out again, split it in half. And something that we saw in the last one is we changed things to sine and cos, or change things into so that both sides of the equation were in the same function. This one, we could change things to sine and cos, but can you see that I could have everything in the same function if I change everything to tan or everything to cotangent? Okay? So there are numerous ways to do a proof. You just decide on strategies and start working through it and simplifying and try to get things to have the same functions on both sides, and then try to get a single fraction on both sides. And then you should be able to, just working through that process, get the left side equal to the right side. People like sine, cos, and tan better than secant, cosecant, and cotangent because they're reciprocal ones, and you're like, ugh. And so generally, the most common thing in this one would people would change things to tan. So I'm going to start with that. Okay? If you change things to tan, this side's already in tan. This side would be 1 over tan minus 1 over 1 over tan. And I like doing this one first because it's very typical to get fractions over fractions and work with things like that in a question. So again, I want to get one fraction on the top. I would need to multiply this 1 by tan theta because it's over 1. Tan theta over tan theta, that gives me a common denominator on the top, so I can subtract and put them together. So now I get the fraction 1 minus tan theta on the top, all over tan theta, and I have 1 over tan theta on the bottom. Now I have a fraction on top, a fraction on the bottom. I can multiply by the reciprocal. Now, wherever things are added and subtracted, those things get grouped together. You remember that from when you were simplifying rational expressions from grade 11, where you factored things and you grouped things together when adding and subtracting. So that 1 minus tan theta is its own thing. It gets multiplied by a tan theta. We're dividing by tan theta here, and only when things are identical can you simplify them. So I would be allowed to simplify those two tan thetas because they're, right, this is connected by multiplying. These are things that are connected by multiplying. I wouldn't be able to cancel out the tan theta on the bottom with the tan theta in the blue brackets because the blue brackets connect it to the minus, to the 1 minus, and that means that's a whole thing. And unless it's identical, you won't be able to simplify that fraction. So now, after simplifying, we're just left with 1 minus tan theta. So our left side is equal to our right side. Okay? When you're doing proofs, after you've proved one, if you want to increase your skills, try proving it in a different way. Try changing something else. Try changing this one to sine and cos. Try changing the tan to cotangent. Try different ways because there's, you know, sometimes they say with all proofs, you know, I've heard it said that, you know, God has a book of proofs, right? And he has in there is like the best proof for everyone. This is a theory out there, or a little story or a legend or whatever you want to say. So if you would go through and you say, well, now for this question, what is the best proof? What is the proof that looks the nicest? What's the shortest proof? What is the most elegant one? Maybe this one, if fractions over fractions get less elegant, maybe there's a better way to do it. So you would, and when you solve it in a different way, right? I split it here. Maybe I decide to change tangent to 1 over cotangent. And then 1 is cotangent over cotangent, which would allow me to go common denominator and add them up. And now I'm done. And that seems a lot shorter, no fraction over fractions. Maybe that's nicer. Is that a nicer proof?
Yeah.
Okay.
Look at mine, it makes no sense. Can't see anything.
So you have different options. Changing things to sine and cos. That might even be uglier than what we did with tan. Okay? So I'm saying that there's often different ways to do a proof. And it's hard for me to say this is the way to do it because sometimes you know, you're going to have to look and you're going to try things. But in practice, you get sort of used to what works better and what doesn't.